Hi everyone, and welcome to another edition of the Code Remix Weekly. With me here is Sam Schneider, and you're in a slightly different setting than you normally are.
I am, Tim. I am in Clearwater, Florida, to attend a couple conferences put on by No Fluff Just Stuff, where Jonathan and I will be speaking. So if any of you in the audience are also attending either the Tech Leader Summit or ArchConf, I hope you will come up and introduce yourself to me. Be lovely to meet some of you in person.
Awesome, yeah. Yeah, good to have you there, and I saw you doing a keynote tonight, so should be good.
Yeah, I think it's actually going to be Jonathan who's doing this keynote, since this is content that I've never presented before. So I'm going to learn how to deliver this speech from watching him do it, and then I'll do it myself. Jonathan's not going to be here next week, so I will deliver it next week, and we'll see if I can improve or put a unique spin on whatever he does.
It's always fun to master a talk in a very short amount of time, and then go on. Okay. Yeah. So as always, we're gonna take you through a bit of the things new over the past 2 weeks. In this case, because some of the US folks were out last week, so we have some catching up to do. And with that, I'm going to take you through a couple of tabs that we have. So. First up, as Sam already mentioned, there is the Tech Leader Summit, where tonight you can watch this presentation on the state of AI in large-scale automated refactoring. I can't tell you much more about that, but Sam can deliver that one as well. And then also new is that there is an article out in the Software Development Times, written by Olga, on AI and if it's ready for mass-scale code refactoring and analysis. So if you want to read that one, I will put a note in the chat, and then you can pick it up from there if you wish to. Now, also new is that you can follow us on Blue Sky. So if you were following us on other platforms before and you've since made the move over with a lot of other tech folks to Blue Sky, then you can now follow us there. And we have the customized handle for the OpenRewrite.github.io. So if you want to check it out, go find us there, go follow us. You'd be one of the first 124, 25 folks to follow us there. And of course, we'll be posting any new releases that we do there, and any new Code Remix sessions will be announced there, such that you can just follow along and catch up on everything that is new. And then this is also probably a good moment to tell you about the release that we did last week. So just I think on Wednesday, with a quick follow-up on Thursday, we did a new release of OpenRewrite and all the associated recipe modules. And we always highlight some of the features that made it in on our announcements going out to X and this guy. So as you can see here, we have now added a functionality where you can use those type references that we've brought up on this call before, but now also see those applied in properties files. So if you are using properties files to manage maybe your Kafka serializers and deserializers, or similar properties configured for Hibernate, then those should now also be picked up for the regular change type and change package recipes that we have. So it's really neat to be, again, reusing that API that we have to apply those changes in more places where you might need to do so. Now, not exactly new, but new to us is that we also support exclusions through preconditions. So Sam, you discovered this, and all you did was add a test that proves that you can get like an exclamation mark in front of a pattern, and you can actually use this pattern, which it's kind of silly. We've had it come up as a question before, and we always thought, no, we'd need a negation somehow in there. Turns out we just had
Turns out we already did it.
Yeah. That's good. So that was a neat discovery, like a unit test only PR, and now we will be sure that it will remain working, even if if we weren't aware of having it before. Now, also new in this release is some fixes already for our Gradle parser. And just today and tomorrow, we already have some additional fixes lined up for the Gradle parser if you are on older versions of Gradle still. So Gradle 5, Gradle 6, the ones still using Groovy 2. Something. Those will get additional fixes for folks who previously were not able to build their projects because they were maybe using some Java classes in their build files or additional parentheses. And we're going to see those issues fixed over the next 2 days, and then probably do a new patch release for folks to pick that up. And we've also been getting a handful of very helpful PRs from the folks at eBay who are working up to a large release, and as part of that they're contributing some fixes to our OpenAPI recipes. So there's a constant stream of improvements coming out there. So if that is a migration that you still have to tackle, know that there's continuous improvements coming out there. There's another PR open, and we're going to get that in tomorrow as well. And then beyond that, there's some other various bits and pieces left and right, such as a new recipe to remove unnecessary returns. So if you have a void method and near the end it has a return statement and it's just not necessary, but it's because you're going to return anyway, then we're just clearing that out with a recipe, and we've made it part of the set of common static analysis issues that we can clear out for you. Also new and applicable for the topic of today is that if you are using JUnit 4 still, and you somehow ended up with arguments in assertions in the incorrect order, then we can now fix that for you. And it'll be part of the demo that we do in the second part of this call. But know that we can fix things for you, even if you thought they weren't broken before. And then finally, from the callouts, we now have a lot more recipes added to our Spring Boot migrations, where previously we did not account for properties that were removed. So we would move properties around, change the key in either the properties files or YAML file, but now we actually also remove properties that have just been removed, unsupported, and probably want to clear those out. And that goes back all the way back to our 2.0 release of Spring Boot. So every minor release in between that and the latest 3.4 release, we'll see those properties removed finally. So pretty neat. And it came through from a community contributor who figured out that we need this, and then wrote the recipes to make it happen, and adjusted the generator that we have for these recipes to make it so. So really pleased to see that through.
You'll love to see it.
Yeah. And of course, if you want to learn more, then you can get the full details of everything that is new through the changelog that we publish on our docs. I'll highlight that link here as well, where you can see that we added various new recipes in there as well. So some new recipes specifically for GitLab, and a few other use cases like the Kubernetes migrations, and those recipes for commenting out properties. So be sure to check that out. And as always, you can upgrade all of that in sync by using our rewrite recipe bar, which lists all the compatible versions of the Maven Gradle plugin, as well as the recipe modules. So that's it in terms of the release. And then perhaps a good reminder, you already saw it on the intro, we have the Code Remix Summit coming up in May next year. And what we are doing there is a hackathon type of thing, as we call it a hack track, which I'm really looking forward to. I've done similar at internal events with customers before, where you get full access to the modern tooling to help improve the code that you have. And as part of the hack track, you'll be able to pair up with us, explore the code that you have, and make the necessary improvements before going back to work after that.
Yeah, I'm going to be there. Tim's going to be there. Lots of people who have deep knowledge of OpenRewrite recipe authorship and the core technology are going to be there to pair with you and work with you on whatever problem you have that you want to create a recipe for. So, it's a great time to just take advantage of having an expert there to sit with you and help out.
Yeah, absolutely. So you can really make the most out of your time there. And of course, just come see us and enjoy sunny Florida in May, which isn't too bad either.
Should
put
be
a
lovely.
link in it. Yep. Put a link in the chat if you want to get your hands on your tickets. There's still a promotion going that we have. If you use this promo code, then you get an additional $300 off. And be sure to check it out, and hope to see you there. So that's it in terms of things that I had wanted to show you here today. So for the updates over the past 2 weeks. And then with that, I think it's time to move on to the main topic for today, which is better assertions with AssertJ. So what I've done for this topic is we're going to take you through a number of anti-patterns that I have found folks use over the past couple of years. And we're going to look at how you can actually fix those in your own code if you have those similar problems as well. And for that, I've written up a very simple demo application, which is also available on GitHub. And I'll share the link for folks that want to explore on their own and take it from there. And with that, we're going to show you these various anti-patterns within my IDE. So I'll switch screens and share my IDE for you. And as you can see here, we have a very simple application with a number of main classes. Very simple stuff. We're not even using any kind of lombok in here. It's just there's some books and there's a bundle of multiple books. Because we're not really interested in this part of the code. We're actually more interested in seeing the various assertions that folks might have been using over the years on this type of code before. So what we're going to do is we're going to switch to the unit test. And you can see that we have a couple of different examples lined up that we'll explore and compare and contrast, and then try to improve using, of course, OpenRewrite recipes to move you over to alternative patterns. So first up, we're going to have a look at how tests were written in the past with JUnit 3. And of course, from time to time, I'll present and I'll ask folks, have you seen this test case class in your code before? And without fail, you see folks raise their hands, which is kind of odd because this is a pattern stemming from JUnit 3, whereas JUnit 4 came out 18 years ago today. Wow. So if you are still seeing test case somewhere, know that your code has not seen the light of day and not been pulled up to more recent versions in 18 years. This is old enough to vote in a lot of countries, old enough to join the army. It's odd. You should be moving.
It's so sad when JUnit 3 test cases go to war. They're just not prepared.
It's like silly stuff. I have backups older than this. It's just. But the patterns that we were using at the time, they are fairly familiar if you've used JUnit 4 before. So if you wanted to do a couple of assertions here, then you just call a method called assert not null or assert equals on the size of this collection that you get back of the books. And then you can assert that various of these books are contained or not contained within the collection. And you can do assertions on the title of the first book as well. So all of this looks okay. But if you're used to JUnit 4, you're probably wondering like, where's my annotation? Where's my test annotation? If you look even closer, you might be wondering like, where are my imports? Like where are these methods coming from? Well, that is that extends JUnit test case that does that for you. So this itself extends assert, and that brings with it a lot of these assertion methods that you were able to use without any kind of imports. But it also limits you because you can only extend, of course, a single class. So you're limited in the types of hierarchies you can do. And there's not a lot of variety in these expressions. And worse still, if these assertions fail, then they're pretty hard to read. So I've written a specific test here to run a couple of assertions that should fail. And if I run this one, you will see that all we get back is an assertion failed error, which isn't great if you want to troubleshoot something. So you're getting back this, we expected a true here on line 33. It wasn't true, and this is all you have to do with. So you have to pretty much guarantee you have to jump into your IDE, go find the test, then run your test, and then figure out, backtrack into what is actually wrong with it, which isn't great. So we can do a lot better with more modern assertion libraries, and I will show a couple of examples as we get to running recipes. But know that this is a reason why you want to be moving away from this particular pattern of using JUnit 3. Now also in there is that you could have some assertions where you're passing in arguments in the incorrect order. So in this case, we have an assert equals, and we assert that the title should match, and then we're first given it the expected value and then the actual value. But in reality, you actually want to have these switched around, because even if you get a helpful exception message, you should be wanting to see this where you had the literal expected first and only then the expected after. And here it's even worse with the assert not null. The compiler won't complain, your unit test won't complain, but you're actually asserting that this string literal is not null, which is pretty bad if you want to have your test. And of course, when you come to the upgrade from JUnit 4 to JUnit 5, they actually swapped these around, which means that if you weren't paying close attention and your compiler didn't complain, you're actually asserting your message is not null, which is pretty terrible.
It'd be pretty hard for a string literal to be null.
And it's pretty hard. And of course, your IDE will warn you if you look at a single class in detail, but I know quite a few folks who do not have the habit of clearing out anything yellow that they see in the IDE, especially if you're doing this at scale and you have a couple hundred classes that you're not all of them going to open in 5
A couple hundred, could easily have a couple thousand classes. Maybe if you're in the kind of organization that still has JUnit 3 tests, as Tim says, decades later, probably no one's going through those with a really fine-tooth comb as part of that upgrade.
Mm-hmm. Absolutely. So what we're going to do for this particular case is we're going to, of course, run a recipe to pull it into the modern day. So for that, I have written a very small rewrite.yaml file. And of course, we're going to leverage the integration that there is for this rewrite.yaml file in the IntelliJ Ultimate Edition. And if we just press play here, then we're going to see that this in the background schedules a recipe run of the AssertJ recipe, and it will apply to the whole project. And then we're going to see specifically what the changes are going to be for the JUnit 3 test class. Now this takes a bit of time to run. Of course, there's ways to speed this up if you use the modern CLI, where we already have the model of your code readily available. But in this case, for a small application, 18 seconds, it's not too bad. If you have a lot of applications, very large applications, then this will be a lot longer. But in this case, it's good enough to explore the results that we might be getting for this particular test class. And for that, we're going to pull up the diff and then maximize that diff and look at some of the changes that you can expect to see when you migrate this JUnit 3 test class to AssertJ. And then first up, we will find that we have migrated this to using JUnit 5 in this case, moving away from the test case to just using JUnit annotations. You'll also find that we are stripping off the prefix of a test method, which is no longer necessary if you're using newer versions of JUnit, because the annotation will guide with which methods are actually tests. And then beyond that, you can find that the general structure of the assertions is kept relatively the same. But the assert not null has been converted to is not null, and all of these are using the same assert that on the books entry here. And then similarly, when it comes to the assertions where I said that they were in the incorrect order, you will find that we have actually fixed the order. These were incorrect and we fixed them, and now we're doing the correct assertions here.
It's the nice thing about using a recipe or other, a mechanical transformation to do something like this. A recipe never forgets, kind of like elephants in that regard, kind of like robot elephants. They never forget that you need to switch the order, whereas a human, distractible as we are, easily can.
Mm-hmm. Yeah, because you'll see that these cases are correctly converted, but a human might have missed that these ones are actually incorrect. So there's a lot of value in running these recipes. And there's one neat thing that I probably should troubleshoot why this is necessary. But we can also run this recipe again and get even more improvements. So I'm gonna, in this case, run it once more. And then we should be seeing more changes still. And of course, it takes those 18 seconds to run. And then we should be expecting to see those improvements here, where we had multiple assertions on books. And with AssertJ, you can actually chain all of those assertions. So instead of having to repeat yourself, you can now run that is not null and it has size check and the various elements it should contain or not contain, and all assert those on a single instance here.
I think maybe we just need to move the recipe that chains the assertions to the end of the recipe list. It might just be an ordering thing.
It is actually at the end already. So that's, so I'm thinking it might be an issue with the underlying types, which of course we do.
Yeah, something might not be updating the type attribution correctly, but then when you rerun the recipe, it rebuilds the LST, recomputes the type attribution, and so then it's correct for the second run. That's probably what it is, yeah.
Mm-hmm. Yeah, so that's, like I said, something I'd love to troubleshoot, but there is quite a lot of recipes under the hood here. And what I would recommend folks do is to run this particular recipe just on any pull request that you receive. We do so in the Midern organization and for the OpenRewrite organization on GitHub, where any pull request will get these recipes applied. And if there's any changes coming from those recipes, then we post a suggestion on the pull request on the relevant lines to adopt that suggestion instead. And this is how we're slowly educating our colleagues on what all is possible with AssertJ and what of that we can actually adopt automatically through these recipes. Because having this concatenated assertions, I think really helps the readability, where you just know I don't have to pay attention to what we're actually asserting on, because all of these are using the exact same instance. So that's pretty neat. You'll also notice here that there's still some room for improvement. There's for the size comparison, we are actually moving over to has size, but for the other ones, there's still some improvements that can be made. So here we invite everyone to contribute recipes to make these changes here, to switch over to the idiomatic way of asserting that you are less than a certain value or greater than a certain value. And of course, now that we have done this conversion, we can pull up the test again. And if we now run the failing test, we will actually get a much improved assertion filling. Where in this case, before we got just a assertion error, now we are getting a message that says, well, we expected a collection of the size 2, but it was actually 3, and these were the elements in there. And if you are a developer who had just touched this code, you probably have an intrinsic feeling of what you did to mess this up, and know to jump directly to the code that you're testing, as opposed to first jump to the JUnit test and then have to work out what you did wrong. So I think pretty neat improvement just from running a single recipe. So then we're going to do similar exercise, but then for various other technologies still. For that, I'm just going to quickly revert the changes that we saw already, such that I can take you through maybe the same pattern, but then apply to Hamcrest assertions. Now, Hamcrest, for those unfamiliar, it is an assertion library roughly the same age as AssertJ, but with the distinction that Hamcrest has over the past 5 years had one release, whereas AssertJ has regular releases probably every month or so. And then the way that you use these libraries is also slightly different. So with AssertJ, you get a single assert that method that you statically import. Whereas with Hamcrest, there is a lot of individual matchers that you can import and have to work out which exactly you need for your particular use case. So in this case, we're doing the same type of assertions, but now with Hamcrest. And you'll find that you can also chain the individual methods to say that is not null value, kind of to make it expressive, but it is 3 imports that you need to do that particular assertion on top of the assert that you already have. So it's a bit more work, and it's also a bit hard to figure out what options are available to you, because you need a different import for each of them. And there's even some cases where it's not immediately obvious, where in this case we have that same collection of books, and we have a method to say contains. And you might think, well, I could just call contains 3 times and it'd be fine. But it turns out that it's not fine. It's actually, that contains is slightly different from the has item that you see here instead. So if we were to run this test, then we get, just on line 42, it now is going to fail. Whereas the, let me quickly pull this up on the bundle. The first one should be effective Java. So the first one is actually contained in there, but it's actually asserting that no, it's actually not matched because it's not an iterable containing this. Whereas it's kind of odd. It's kind of, well, it's not immediately clear when you should use has item or when you should use contains. So what we're going to do again to improve these tests is just to run the exact same recipe that we had before. We're going to roll back the changes, we're going to run the recipe, we're going to fill those 18 seconds waiting for the recipe to run. And then we're going to quickly explore the changes that are done by this particular recipe. And for that, I'll pull it up as soon as it opens here. Now, one thing that is nice about Hamcrest is that you're able to write some custom matchers. And the Spring team has done so as well. But the Spring team has also learned that you can do more expressive assertions with AssertJ. So now there is a lot of assertions for WebMVC still written in Hamcrest. Whereas there is a new API out there, we're using AssertJ style of assertions. And then of course the challenge for folks to switch from one to the other. And we're hoping that recipes will play a role in doing that migration. So let's pull up the differences here for the Hamcrest test. You'll find that all these wildcard imports that we had before are actually replaced by that singular import that we now have. Whereas the assertions, they read pretty much the same. So the is not null value is just is not null. And the has size is just the exact same, but with the comma removed and replaced by a new method call. And all of this then becomes more clear when you move to the previously failing test, where we had, before we had that contains, and it turns out that the semantics of that are that it contains exactly this book, where it is an iterable containing multiple books, and now finally you know, well, that's not correct, we can't assert that 3 times over the same collection, we should probably do that in a different way. The correct way would be using a comma here, and then the next book, and the next book, and the next book. But like I said, it's very helpful to have the AssertJ style of assertions, which are just slightly better named, more discoverable as well, because you can just call on any assert that books. You can call, just press dot, and you get a whole wide range of pop-ups in your IDE telling you exactly all the different things that you can assert on a collection here. Now, of course, the pop-up isn't showing because I'm only sharing a window, but trust me, it's a lot more discoverable when you do this type of work. So that's it for comparing the Hamcrest to AssertJ, and then there is a couple more that I want to run you through. So hopefully you'll not be using Hamcrest or JUnit 3 anymore, but JUnit 4 is still pretty common. And this, of course, is I think well known by now. It's you mostly use assert true and assert false or assert equals or not null, but it's all the assertions that we know. But there's also that risk of, again, having arguments in the incorrect order and asserting that an exception is thrown in JUnit 4. It is slightly awkward. You can use either the style of an expected exception on the test annotation or the style of a rule with expected exception. And then you can throw call methods that say, well, any exception that you get from now on should be an illegal argument exception with this message. And then you call a method, goes boom. But all of it is slightly outdated. If you think to the release date of JUnit 5, that is now 7 years ago. So 18 years for JUnit 4, 7 years for JUnit 5. So really, if you're seeing JUnit 4, you've not been updating things for quite a long time. So we can fix all of these again, and then see those improvements trickle in. And again, we're gonna run the recipe, and then compare the results. Now, one thing you had to do with JUnit 4 was that all your test classes had to be public, all your test methods had to be public, and that unfortunately had the effect where folks would try to share code between classes, because you can call any method left and right. There'd be confusing patterns where someone is calling one test method from a different test method. And now, fortunately, with JUnit 5, you can actually remove that public modifier from your test classes and your test methods to kind of counter that pattern. And we also do it, run a recipe to make it such that you don't do that anymore. So wherever we can, we remove the public modifiers and then move you over to those better assertions. And let me just run the recipe once more, because of that one small imperfection that we have with the types. And then we can see that these assertions are again chained into that assert that books with multiple assertions on a single instance. So this, I think, looks a lot better. And again, you will find that we have swapped these or the order of these incorrect arguments around to actually fix things here. Now also, as of the last release for JUnit 4, where before we only did that for JUnit 5. And you will find that we are, we've changed how we are now asserting that an exception is found. So like I said before, we had that test rule, and now we are calling a new method with the assert throws. And we're passing in the boom method. And then we're able to get back the exception that was thrown and do further assertions on the messages we extract from there.
You know, I'd never noticed you could do that with assert throws. That's handy.
It is very handy. And like, you didn't have to know that, because if you were doing that previously, we actually apply that change for you. So we will pick it up where that thrown has an expected message, and we will turn it into that assignment, and then the get message contains boom. So it's just, again, one of those things where you don't have to learn that you can do that. You can just see it appear in your code, and then be able to do these assertions this way. So again, quite helpful, very easy to apply and run and see these improvements. And now we've already gone from JUnit 3 and Hamcrest and JUnit 4 onto JUnit Jupyter. And from there onwards to AssertJ. But there's one more example that I want to show you, which kind of contrasts the patterns that we see in AssertJ versus the JUnit. And for that, we're going to open the AssertJ test class, which we have, where by now we know the familiar patterns, the things that we can improve, and collapse these assert books into just a single assert on those books. But what I want to call out here is that we have a AssertJ method where the assert throws thrown by is being used, and you will find that these statements don't actually have to be within that assert throws thrown by. You could write it this way, and you would get the exact same behavior. Now, for our JUnit 4 to 5 migration, and then our JUnit 5 recipes, we actually have an improvement that would pull those statements out of the assertion block and put them ahead of the assert throws. But unfortunately, we don't yet have a direct parallel for that in our AssertJ recipes. So we can run this recipe, and we will not be seeing that change, unfortunately, yet. So that's an improvement that you get if you're coming from Hamcrest, JUnit, and going to AssertJ, that we will fix that for you while you are still on JUnit 5, and then pull you through to AssertJ. but unfortunately we can't fix it yet for you in AssertJ. So this is again something where we invite folks to join the project, go to rewrite testing frameworks, and find these various ways where you can write a recipe. There's a direct parallel with a recipe in JUnit to apply this fix for AssertJ as well. And then with that, I think we have shown you quite a few ways in which you can improve your tests, no matter what you're coming from. Each time going to AssertJ and the most expressive assertions that you can do with AssertJ, just by running a simple recipe. And then to do this on your own projects, of course, all you need is that rewrite YAML file, or you can use the command that you see here in the README to get these better assertions applied to your projects. So I hope that is helpful to folks. And of course, we very much hope that you would also consider contributing to these recipes. Because what is maybe fun to show you is a bit of how these recipes are implemented. So if I were to switch to the Rewrite Testing Frameworks project, you can see that our Hamcrest recipes, those are mostly declarative recipes, where we have a single recipe which can take some arguments, and we just apply that repeatedly with different arguments to move you over from this Hamcrest matcher to this AssertJ replacement for a given type. And this is a very long list of these types of migrations that we're doing for you, no matter which Hamcrest static import you were using, to get you onto the better AssertJ replacement. Includes negation and all of that. And then from there, if you are moving from Hamcrest to AssertJ, you could still be using JUnit 4. If you want to move to JUnit 5, get those public modifiers removed and all of that, those recipes are all in this JUnit 5 YAML file. And then if you already have done all of that, moving you from Hamcrest to AssertJ and from JUnit to AssertJ, then there's still some best practices you can repeatedly apply, like I said, on pull request to get these improvements. And some of these are contributed by our friends at Picnic. They have a lot of refaster style recipes to replace specific assertions patterns with better replacements that are just more idiomatic. And we've been fortunate enough through our collaboration to make these part of the recipes that we run on Java 8, despite their recipes having been developed for Java 17. So pretty neat in that collaboration that all of this just works. And then finally, we have that collapse of consecutive AssertJ statements. Should be collapsing things in one go. But of course, yeah, now you'll find that you might need a second invocation just to get that good. So that's it on how these recipes can help improve your code, and also how you can find the recipes and how they're implemented if you want to expand on this just a bit. So with that, I do see we have a couple of questions in the chat as well. So let me try to pull up the first question here. So this is from Ramachandran Narapanyapan. I'm not sure whether it's the right time or forum to ask this. We are using OpenRewrite Maven plugin to fix some static code analysis issues. I think this is probably a good question to ask in the Slack that we have. Of course, you're welcome to ask questions throughout this call as well. But this one specifically, I don't think has anything to do with the topic at hand for today. So let's move that over to the Slack and tackle it over there. So that, I think then mostly concludes what I wanted to present today. So I'll very briefly take you through a couple of tabs if you want to find exactly what we did today. So the Better Assertions demo project that I took you through, that is available through my GitHub account. If you go to github.com/better assertions, then you will get this demo application as well as the recipe that we use there for the replacements. And then beyond that, of course, there's the various projects that we looked at today. So there's the JUnit 4 documentation with the various outdated prems you had there, the JUnit 5 and their migration guide that is here, and of course we've aimed to automate most of this, and as well as adopting features from it. Then Hamcrest, like I said, they have these common matches. You can browse those on the Hamcrest tutorial. But ideally, if we find that there's anything that you're using and we're not yet automatically converting, let us know, send us a pull request or a question, and we'll get that converted as well. And the folks at AssertJ, we're very fortunate. They have actually listed the recipe that you saw used today in their migration guide. So if you're coming to the AssertJ project and you're finding that you want to use the assertions in AssertJ to the best way possible, they know that OpenRewrite is a thing and it can help you there. And then from there, of course, you can also, it links out to our docs.
Oh no.
There's actually a PR out to fix this link for them already. So probably by tomorrow that link will work again. And this then takes you to the composite recipes that we have to actually do all of the improvements that you saw today. So I hope all of that is helpful to you. And then, with that, I just want to thank you all for joining me in this exploration of outdated tested plannings and how you could be doing better. And of course, there's more topics that we haven't touched on yet. You can be doing things like moving only your tests over to a newer Java version and leverage the recipes that we have there, which is a pattern that we've come to adopt at Modern, which is treating us very well to be able to use all the latest Java versions only in the tests, and then on main just remain compatible with Java 8 for the users that are still using that version.
Yeah, it's been really handy, man. The OpenRewrite. I have seen a company that was doing some in-house recipe development, but hadn't figured out how to do that, and so they had OpenRewrite tests running on Java 8, so no multi-line strings. It was so painful to read and edit and debug. So if you're ever writing a test and doing a string concatenation for a multi-line string, you don't have to. You can run just the tests on Java 17 or Java 21 and still have the main code, compile and run on Java 8 or 11 or whatever old thing you're stuck on. But obviously better to get migrated to the new thing wholesale, but baby steps can make that easier.
Yeah, and it's especially helpful when there's maybe like reasons, like your deployment environment, there's some reason why you can't move to your main code to Java 17 or 21. But it is really nice to not feel every day that you're stuck in the past programming on something from 2010 or about. So be sure to look for that pattern as well to move your tests only to the newer Java versions. And then, with that, I think you've seen quite a bit of how you can improve your tests by running just a simple OpenRewrite recipe.
Yeah, thank you, Tim. Very educational.
Yeah. So then, thanks everyone for joining us. Sam, good luck with the presentations these coming weeks, and then
thanks, Tim.
Hope to see you all next week. So next week it's going to be a live coding session where you're going to leverage the link that we have between the types and the dependencies that are coming from to then find unused types to clear out. It's going to be a lot of fun. And then, something that we've been wanting to do for quite a while now. And then, of course, with a live coding session, we have a full hour to get it done. So
exactly.
Forward to that. So then, until then, we'll be available through Slack for questions or anything, and hope to see you next week.
Yeah. Thanks, everyone.
Thanks all.